Today's lesson is on measuring angles, so let's first start by talking about what an angle is. An angle is formed by two different rays that have the same initial point. The rays in an angle are called the sides of the angle, and the initial point of each of the rays is called the vertex. So as you all know, an angle looks like this. But what you may not have ever really thought about is that this is two rays, each sharing the same endpoint. Here's one ray. Here's the other ray. And that's what makes an angle. All right, and I copied a little box from your book talking about the different ways you can name an angle. You got three ways. If you got this angle here, you can call the angle by its vertex. So we could call this angle A. If you have the 3 points, you can either name it angle BAC or angle CAB. Those are the same angles. Or as in this picture, we have a little 1 in there, so we can call that angle 1 as well. If you're naming an angle with 3 letters, you always have to have the vertex of the angle in the middle. Have to have the vertex be the middle letter. All right, now the interior of an angle is the region containing all the points between the two sides of the angle. So as you can see in this picture, all the green here, that's the interior of the angle, and of course the yellow is the exterior. The exterior contains all the points outside the angle. Interior contains all the points inside. And remember that the sides of the angle go on infinitely, so this would still be interior out here. Okay, now let's talk about types of angles. An angle that measures 90 degrees, we all know, is a right angle. And you'll probably see if you have an angle, let's say you had an angle and you see this little box designation in the corner, that means it's a right angle. An angle that measures between 0 and 90 degrees is an acute angle. So it's going to look something like this. An angle that measures between 90 and 180 degrees is an obtuse angle. And of course it'll look something like that. And if my angle measures 180 degrees exactly, then we know that's a straight angle. And of course it's still made of two rays. They're just going in opposite directions. So there's my angle measure of 180 degrees. And then if I got an angle that measures more than 180 degrees, we call that a reflex angle. And what that would look like is, let's say, I've got this. That measure right there is greater than 180, so that would be called a reflex angle. All right, now we've got a couple of postulates, so you want to be sure to make flashcards for these. Consider point A on one side of OB. So here's A right here in our picture. The rays of the form OA, I'm thinking, yeah, we got some notation left off here. We need to put our ray symbols up here. Remember, notation, very important. I am having a little problem with my math type program, and some of my symbols aren't showing up when I print the document, so just make sure you get all your notation correct. So consider point A on one side of OB. The rays of the form OA can be matched 1-to-1 with the real numbers from 0 to 180. And if you look at your protractor here, you see here is 0, and it goes all the way around to 180 on this other side. So the measure, we can use that to measure angle AOB. And the measure of AOB is equal to the absolute value. Remember, we used something like this when we measured segments. The absolute value of the difference between the real numbers. So for instance, what are the measures of angle LKN? So let's just start with that one. And when I'm talking about the measure of an angle, I got to be sure to put that little m out there. The measure of angle LKN, okay, is the absolute value. What did our little postulate say? The absolute value of the difference between the real numbers for those rays. So we're looking at LKN here. So it's kind of hard to see on this board, but what I think this measure is 145 minus 0. So that's 145 degrees. All right, the measure of angle Jkl would be the absolute value. Here's Jkl, Jkl right there. So that would be 90, because you see J is up here at 90. 90 minus 145, which is the absolute value of, sorry, negative 55. That's negative 55. So that would be a 55-degree angle, because remember, absolute value is always positive. And then we got Jkn, measure of angle Jkn. So where are we? Jkn. So that would be the absolute value of 90 minus 0, which is going to give me 90 degrees. So that's how we use our protractor and the protractor postulate to measure angles. All right, let's learn another very important term here about angles with the same measure. Angles with the same measure are congruent, a term you will use many, many, many times in this course. And the notation for congruence is this symbol right here. So that's what we're going to use to denote congruence. You can mark angles with arcs to show that they are congruent. So here, when I look at this angle A, and it has this mark, and I look at this angle B, and it has this mark, that tells me that angle A is congruent to angle B. So make sure you know this notation. If the measure of angle A equals the measure of angle B, then I know that angle A is congruent to angle B. And please notice that when I'm talking about congruence, I'm not talking about measures, I'm talking about the actual angles themselves. Be very careful with your notation. Okay, we got another postulate. The angle addition postulate says if P is in the interior of angle RST, so here's RST, P's definitely on the interior because right there it is. Then what I know is that the measure of angle RSP plus the measure of angle PST equals the measure of that whole angle RST. Pretty much like the segment addition postulate. Okay, so here's an example for us. The measure of angle BCY, so that's this one right in here. Measure of angle BCY is 8x minus 2. The measure of YCD, which is this one right in here, is, I'm not going to put an arc on it because these two aren't congruent. So don't put the same arc on two angles that aren't congruent. Measure of YCD is 104. And the measure of BCD, which is the large angle, is 20 minus 2x. So I want to find the measure of angle BCD. So I'm going to start by writing the angle addition postulate. So I know that the measure of angle BCY plus the measure of angle YCD equals the measure of angle BCD. That's the angle addition postulate right there. So let's substitute what we know. Measure of BCY is 8x minus 2. Measure of angle YCD is 104. And the measure of angle BCD is 20x minus 6. So now we've just got a simple linear algebraic equation to solve. So I'm going to subtract 20x from both sides. I got 8x minus 20x equals negative 6 plus 2 minus 104. And when I put all this together, I get, what do I get? Negative 12x equals negative 108. So x is going to be 9. X is 9, right? But that's not what it asked me. It doesn't ask me what x is, so let's be sure that we answer the question. So let me come over this way. The measure of angle BCD, I'm just going to use substitution now, is 20 times 9 minus 6. So that's 180 minus 6, which is 174 degrees. All right? Be very careful that you're sure to answer the question you're asked. Okay, there's one more example here, so I think this would be a good time for you to pause and work this problem and come back up, and I'll have the answer posted. All right, I got 23 degrees there just by using the angle addition postulate and substitution. Please check me out. First you got to solve for x, then you got to plug that value in to find the measure of CDQ. Again, please check that, make sure I didn't make an error. Write yourself a summary or find another problem or two from your textbook to work, and we'll see you next time.